Greetings, Earth enthusiasts. If you ever wondered about the incredible perspectives our planet has to offer from high above, you're in the right place. I am Dr. Clive Coetzee, and I'm thrilled to be your guide on this captivating journey into the world of remote sensing. Welcome. And please remember to like, subscribe to, and share this video. Thank you. I haven't posted, I think, for 8 days now, which is quite kind of strange. It's a little bit unusual, but unfortunately, it's a couple of urgent priorities that came on my desk. So I had to solve this out. So my apologies. Let's see if we can keep it up. The journey has came to a very, very brief stop, but let's pedal to the metal and let's continue again. So basically what I've been asked over the last week, and it stems pretty much from this channel, is a couple of interesting things that people wanted. And I use quite a lot of these scripts and codes to generate those images and the data that the people required. So I haven't forgotten about our land surface temperatures, creating our urban heat maps. I haven't forgotten. We're still busy. We haven't finished that. But as I said, there's a temporary detour. So I've done these two videos, 158 and 159, in creating loops. And I had a lot of people that asked me about this looping and how to use the loop, etc., etc. And to be very honest, I've used it now quite a bit of time, time again. I've used these looping. But anyway, just before I continue, please, boys and girls, we're standing at 472 subscribers. Let's please press those subscription buttons. Please. Let's grow the channel together. With your support, we can grow it. We can keep on with this journey. So thank you. I appreciate it. Okay, so let's go to, so what I was asked, let me go to this one. So what I was asked is to generate various statistics for each of, in South Africa, let me first one step back. In South Africa, we have around 213 municipalities. I'm not sure what it's in other countries, counties, I presume, or something to that effect. But in essence, it's a third administrative level. After national, provincial, we get municipalities. So in South Africa, we have roughly about 213. So municipalities. There they are. I don't know why it says that. I need to change this. Is municipalities. Okay, municipalities. Let's rerun it again quickly. Okay, so yeah, so that's good. There we go. So each of these areas represents a municipality, and there's 213 of these municipalities. So what I was asked is to say, okay, to generate various statistics for each municipality, for its night light intensity for a particular year. In this case, the year was 2023. So I was asked to generate statistics, nighttime light intensity statistics for each of these 213 municipalities for the year 2023. So that was what I was asked. Okay, so it's basically like doing a zonal statistic in QGIS, where you have image and then you allocate or you generate the statistics from the raster image for particular polygons or particular regions. So it's basically zonal statistics in Earth Engine. So that's basically what we've done. So first of all, as normal, okay, let's first go to my municipalities. This polygon here, the municipalities, it sits there. So it's loaded as an asset. It's a shape file. Okay, it's a shape file. So if I open that asset, this region of interest of mine, with the municipalities, you'll see it has various columns. I think there's 16 columns. Most of the columns are rubbish, but there's 1 or 2 columns that's important. So there's my column. So I've got an index value. Is what type of municipality is it? Is it a metro? Is it a local? Abbreviation, date, etc. But the important thing is each of these have a unique name. Okay, so unique name, there it sits. So I'm interested in this column. So what we want to do is to calculate for each of these municipalities, for let's say Buffalo City Municipality, Nelson Mandela Bay Municipality, Kucha, Kaukama, Ndabande, Sundays River, Makana, Blue Crane, Bayers Nordia, I'm not going to pronounce it, I don't know how to. For each of these 213 municipalities, I want to calculate various nighttime statistics, nighttime light intensity statistics. So what was the mean statistic? What was the median? What was the maximum? What is the sum of the night lights, etc., etc. So various statistics that I want to calculate for each of these municipalities for this particular period, 213. Now, you should know that this is an image collection, which is a monthly, so there's 12 images in this period. Okay, so we can display that image or that image collection. We can display as either as a sum image, meaning all 12 together, or a medium image or a median image. So we're going to display for each of those 3 statistics the image. And then for each of these 3 statistics, we're going to calculate 3 statistics. So for the median statistic, we're going to calculate. Yeah, so remember, as I said, there is 12 images. So we're going to calculate some image, meaning the night lights for those individual 12 months. We're going to add it. Then we're going to calculate a median image and a mean image. So we'll have 3 images, each image with different values for each night light pixel. And then what we're going to do is we're going to say, okay, now we need the zonal statistics. We need to aggregate those individual pixels and calculate that statistic for each of these municipalities. So therefore, there will be a sum image, a median image, and a mean image. And so for each of those 3 images, we're going to calculate 3 statistics, i.e. sum, mean, and a median. So therefore, we're going to create for our sum image, a sum, median, and mean statistic. That's 3 statistics. Then for our mean image, we're also going to calculate the sum, median, and mean image. That's 6 statistics. Then for our median image, we're going to calculate sum, median, and mean statistic. So each of those 3 images, we're going to calculate 3 statistics. Okay, so ultimately we're going to have 9 statistics calculated for each of these 213 municipalities. Now, if we only have a sum image, then we only have 3 statistics. Of that sum, we're going to, because remember, there may be 20, 30, 40, 1,000 pixels for each municipality. Okay, and we want a singular number for that night light intensity number for that municipality. Okay, so if we overlay it, okay, so let's overlay it, let's say, with a sum image. Okay, so let's just make it a little bit more transparent. Okay, so let's zoom in, for example. Let's zoom in, just to explain this in a little bit more detail. Okay, so let's quickly go to a municipality. Okay, so you see this is a municipal area here. Okay, this area. I don't know what its name is. Let's have a look and see what is the name of this thing. It's called, let's have a look and see. It's called Fazeli. It's Metsimaholo Municipality. Metsimaholo Municipality. This one here. Okay. So you'll see it has a number of nighttime light pixels. So now we want one nighttime light statistic for this whole municipality derived from all these night life pixels. You'll see these night life pixels are fairly small. I can't remember what the scale is, but they're not very big. You'll see there they are. So the question is, what statistic do we derive? So we can do the sum, meaning add all of them. So this one, we add it, or we take all of them and calculate a mean or a median. So that's why I'm saying, and then, but this is based on the sum image. Now we can add the mean image. You see the mean image looks a little bit different. Let's make it. Okay, so that was now, okay. So that's the mean image. That's the sum image. And you'll see the numbers are different. The sum is 14, mean is 1, and median is 1. So there's 3 images. Each represent the night light intensity in a different format. And therefore, and then, as I said, we want to calculate 3 statistics for each of those images. And that will give us a range of nighttime light intensity statistics for each municipality. And then obviously we can decide which one we're going to go, which one we're not going to go, etc., and how they compare. Nonetheless, okay. So I hope that makes sense. It took me a bit of time to figure this one out. Okay. So first of all, we add our asset, our region of interest, with those columns, with the 213 municipalities. Then we're going to decide our source. Okay, there's our normal clipping tool, etc., etc. Then we're going to calculate our or generate our image, or include our image collection, our data set. In this case, it's night light intensity. It could be anything else, to be very honest. Our band and our date. Again, we can have different dates. I'm just using that. You can do it for only a month. You can do it for 6 months. You can do it for 10 years. Doesn't matter. And I said, now from this image collection, which is 12 images, we create 3 images. And this is a reducer. We reduce these 12 images. A sum reducer, a mean reducer, and a medium reducer. So now we're going to have 3 images. And here they are. Okay, let me just make it darker again. And there they are. Okay, so let me zoom out again. And that is my 3 images. So that's my sum image, meaning the sum of lights, meaning adding all these lights together. There's my mean. Well, it's coming. There's my mean image. You'll see it's not major different. Visually, it's not different. And there's my median image. Okay, it's going to get there. At some point. There we go. There's my median image. So you'll see visually there's some differences. Obviously, the sum will have higher values. The mean and median will be very close together in terms of its values, etc. Okay, so there's my 3 images. Now I need to calculate 3 statistics for each of these images. Remember, this is now reduced. This is the 12 images reduced. It should be 2023, not 2022. My apologies for that. Anyway, there's our visualization parameters, and we're just adding them to our maps. Okay, adding out to our layers. So up to here, we haven't really done anything dramatic, anything strange. Okay, now the magic starts. Now, obviously, we have these 3 images. We now need to calculate for each image, meaning for this sum image, for this mean image, median image, 3 statistics. And once we've calculated those 3 statistics, we need to add it to our region of interest, to this table. Okay, for this table, this feature collection. Okay, not image collection, feature collection. We need to add it back, meaning zonal statistics. Okay, so what are we going to do? How are we going to do this? Okay, so let's open this a little bit. First of all, we're going to calculate the 3 images, or the statistics. Okay, we're going to calculate the statistics. Okay, remember, it's the sum image. So there's my sum image. Okay, and I'm going to calculate on that sum image the sum, the mean, and the median. Okay, so I'm calculating on this image, so it would be this image now. This image, I'm calculating the sum, the mean, and the median. Okay, I'm calculating the sum, the mean, and the median for this image based on my region of interest. Now, This is very important because this influences the data itself. So this scaling here needs to be as close as possible, or should be ideally exactly the same as the scaling of the data set itself. So to get the scale of the data set, we just simply go to the data set, and it while we're searching for this, it makes a huge difference. It does. So it makes a massive difference if you use different scaling factors. Okay, so please use um, the scaling factor as close as possible. So it's 463.83, and we should actually update it with that number itself. So in fact, what we should have is that actual number. And it does make a difference. It actually does make a big difference. So take note of that. Your scaling factor here needs to be as closely as possible to the actual scale factor as it is portrayed in the data source, in the catalog. Okay, so that number there. So the resolution there and the scaling value of there should be identical, also as close as possible to identical. And it does make a big difference. Okay, it does make a huge difference. So as I said, please take note of that. Okay, so let me just do these three as well, these two as well. And as I said, I take now each of these images, sum image, and I get a sum, a mean, and a median statistics. I take the mean image, this one here, and I get a sum, a mean, and a median image. And then I take my median image, statistics, sorry. I take my median image and get a sum, mean, and median statistic for that. Okay, so please bear in mind. So please bear in mind that, as I said, these scaling factors are very important. Okay, so then it's normal, the three statistics. So now we'll have 1, 2, 3 statistics for my sum, 1, 2, 3 statistics for my mean image, and 1, 2, 3 statistics for my median image. So now I'll have 9 images, 9 statistics. Now we have to combine those three because we want to add them to a single. We want to add them to a single table. We want to add them to this table, this feature collection. Okay, so now we're going to do is we're going to add them together. Okay, so we're going to say create a variable called merge stats. Okay, and this merge stats includes the sum image, the sum of the sum image, the mean of the sum image, the median of the sum image, the sum of the mean image, the mean of the mean image, the median of the mean image, the sum of the median, etc. You get the idea. So we're going to add these 9 statistics now together. Remember, that's the 9 statistics that we've generated here from our 3 different images. So we're going to add them here. This is just the system index, and the system index is just from the beginning to the end. Okay, so there's our sum statistics, our mean statistics. Remember our sum statistics. There's our sum stats. There it is. So we're adding our sum stats, we're adding our mean stats, and we're adding our median stats. And then basically we just return them into these numbers. Okay, so this is now, we've created a variable called merge statistic, which basically just contains those 9 statistics, 3 statistics of each of those 3 images. So that's what we're doing here. We're just merging all this. And basically what we then say is we're going to print it. Well, I'm not going to worry about that. And then we're going to export it. Okay, then we're going to export it, our merge stats. We're going to export it. Now, the system index, let's just quickly go into our asset again. Let me just quickly go into, sorry, now where's my asset again? Sorry, I should have stayed there. Okay, so let's click on my asset again. Just waiting. Let's go to, just waiting for the features to come up. Okay. Remember, there's my system index. Okay, so it's going to put the values. So that's if you, okay, so can I move this? No, I can't move this. But that's the system index, which is basically that column. So that's how it's going to identify the 213 municipalities. So it's going to search for that system index, that column there, and it's going to then use each of those cells within those columns or rows in that columns to populate the data. So I could put in here any of the names within my feature collection, within my table. So we could change it to, for example, sorry, it's a bit pity we can't move this thing. Okay, we could, for example, use any of these. That's the identifier. So in this case, it's using the system index. So it will recognize that as a municipality or that as a polygon, and it will calculate the statistics. It will recognize, identify this as a polygon, and it will calculate the 9 statistics for that one. So you'll have then 9 columns for each of these 213 rows, or for each of these 213 municipalities, and identifies the polygons based on this column. Hope that makes sense. Okay, so system index here, which is the same as the system index there. Okay, so it created that column, and that column it now uses to identify each of these municipalities. So now we've said, okay, each of these will have a unique identifier, which is in the system index, each of these ones. So calculate these statistics for each of these municipalities based on this unique identifier. Okay, I hope that makes sense. That's the importance of this one. Say that's right. Filter it equal to the system index, and then get the system index, get the name of that. Okay, and then we're going to export it. We're going to export it as a CSV file. We're going to export the merge stats. Okay, so this is the merge stats. Okay, and that's now how it looks. Remember, it's called Nightlight Statistics by Region of Interest, which is Nightlight of this. We just simply press run, and then it's going to save it to our Google folder, and then from Google folder, we simply just going to download it to my workstation. And this is how it looks. This is how it looks. So what we're going to do, obviously this is in CSV. So I just need to convert it from CSV into Excel. So first of all, I go to data, text to columns, and we can just say we're going to do it by comma, and we're going to press finish. I'm not going to do it anything more, and you'll see there it sits. Okay, so let's just open it up. Okay, so there's the normal columns that was in the feature collection in the table itself. Okay, and there is now all the statistics. There's there it's the mean count. Okay, so the count. So I've added it's counting the number of cells, pixels. So in this area there was a 10,252 nightlight pixels. And the sum of that is 620. The mean, etc. So there's the variables. 1, 2, 3, 4, 5, 6. So where's the other 3? Count. Why is it doing count? It shouldn't do count. This is the count. Where is count now? Okay, it's because these names are the same. So we actually should use different names. That's where the issue sits. Okay, so we've got count. You see these counts are exactly the same. So in fact, what we can do is we can hide this one. We're not going to use that, and sum count. We're not going to use it. So there's the mean sum, mean mean, median sum, median mean, sum sum, and sum mean. So it didn't the mean sum, mean mean, mean median. So that's where the names, the confusion gets in. It gets confused with all these names. Okay, but nonetheless, that we can sort out. It gives you the statistics. And so if let's hide, we're going to go to that one there. We're going to hide this. Let's hide the date as well. I'm not going to interested in the date. The shape area and stuff, let's hide that as well. I'm not interested. Okay, so there's my Overstrand municipality. Within Overstrand, it's got 10,252 pixels, nighttime light intensity pixels. The sum, the mean of this, okay, this is the mean image, and the sum of the mean image of this 10,000 is 6,205. The mean, meaning this divided by this, will be 6,000. The median of the sum is 6,131. You can see it's not that different from one another, and the sum is sum. Sum mean, you can see it's the mean and the median statistics are roughly the similar, and the sum obviously is a little bit higher. But in general, it gives you now an idea of the different statistics for each of these 213 municipalities. So basically, the zonal statistics for the year 2023 is nighttime light intensity based on the reduced image, a reduced sum image, a reduced median image, and a reduced mean image. So that's quite neat. So I don't have to export this image. Well, I can't export this image to so I can't export this image to QGIS because it's way, way, way too big. So I can't do it. So I have to go and take it from I have to take it from the source itself, but I don't want to do that. I want to do everything in QGIS, in Earth Engine. So doing the zonal statistics within Earth Engine, and this is roughly how you do it. There's also a different option that I've also used. Okay, sum, mean, and mean statistics for each polygon in the ROI. So again, mean stats, sum stats, which will be a sum, the mean stats, a mean, and the median statistics. Yeah, and so forth. But so there is a second option, but you can see it still roughly do the same thing. It's a mean, and median, and it uses a sum index. It uses a sum index. I just wanted to quickly look and see. I think I have opened this one here is actually this here, because you see it's sum, mean, and median. So anyway, but it's basically the same. It's just different ways of calculating the same thing. So I've just used different techniques or different methods or different codes. But generally, just to check, they are very, very similar. In fact, they are almost 100% similar. So there's my 213 municipalities. You'll see there's 213 of them. 213 municipalities, each with the number of pixels, nighttime light pixels, and then various statistics based on the images. For my 213. Now we can calculate who had the most, who had the least, blah, 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 blah. We can do all those calculations. Okay, so that is basically zonal statistics within Earth Engine using nighttime lights for my 213 municipalities. Cool. Great. Okay, that is it for this video tutorial. I hope you found it interesting and relevant. And yeah, go play around with it. You'll be amazed. You'll be amazed. Yeah, boys and girls, thank you very much for joining me. I really appreciate your company. Welcome. And thanks for joining me on this remote sensing journey. We're exploring unknown territories. We're doing it together, and hopefully we learn, we get better as we go along, as we proceed. Please remember to like, subscribe, share the video. Your support is greatly appreciated. Feel free to send me some comments. I will respond to your comments as soon as I can. And with that said, thank you very much again, and I'll see you on the other side.